Today we are going to discuss the topic closed pack structure in solids. That is closed packing. We know crystals are made up of different particles, either in atoms, molecules or ions. And each particles considered as a sphere. Each considered as a sphere, just like spherical shape. So, if you place the spheres closely, we will get different types of packing. Packing may be in one dimension, two dimension, or in three dimension. So, in closed packing in one dimension, it will be formed like this. When you place the sphere horizontally or vertically by touching one another, it will be formed like this. One sphere touching another sphere directly. Direct, it is horizontal, or you can do vertically, or vertically. So it can be for either one direction, either horizontally or vertically, but sphere will be touched directly. So in this case, it is a closed packing of one dimension, that is linearly arranged. Horizontally is placed, linearly arranged. But if you see, suppose you take one sphere. Around this sphere, how many spheres are directly attached? 2 and 3. So around 2 spheres directly attached. That's why we can say the coordination sphere of number 1 is 2, because this sphere directly attached to 2 spheres. So coordination number of this type of packing is 2. Coordination number means number of sphere directly touching to particular spheres. That is called coordination number. Here coordination number will be 2. So come to two-dimensional packing. Closed packing in 2 dimensions. It is generally 2 types. That is square closed packing, another is hexagonal closed packing. In square closed packing, how the spheres are placed? This is your horizontal placing and this is your vertical placing. So spheres are placed directly touching one by one, horizontally and vertically. Directly touching. So this type of arrangement, this type of packing is called square closed packing. But here one thing you see, suppose consider this sphere. This middle one is directly attached to 1, 2, 3 and 4. So 4 spheres directly attached to this middle sphere. If you join all these neighboring spheres, if you join, then the shape will be just like a square. That's why it is called square close packing because it produces square shape. Any spheres you take and the sphere which directly attached the neighboring sphere, the shape will be square. That's why it is called square close packing. And here you see the coordination number. Coordination number will be, if you count this middle sphere directly attached to 1, 2, 3, 4. That's the coordination number is 4. Coordination number of middle sphere is 4. Then come to hexagonal close packing. In hexagonal close packing, you have to take some different way. Different way means you see how they are placed. I have drawn also one. I will show you. This type of packing is your square close packing. Horizontally, vertically. So directly touching. So this type of arrangement is a square close packing. Then come to your hexagonal close packing. In hexagonal close packing, how it will form? First layer is formed. In the first, this is a first layer, but first line, second line will be formed just at the depression of two sphere. At the depression of two sphere, you will place the second line. Second line of the sphere you will place at the depression of the first line. Similarly, third line you will produce at the depression of two layers. So you see this arrangement. Here one layer, then second layer is just at the depression. Then below also at the depression of two, one layer. Depression of two, another. So if you do like this is the difference between square close packing and hexagonal close packing. Here the hexagonal close packing, the second line will be formed at the depression. But in the square close packing, directly sphere will be placed directly. No at the depression. Horizontally and vertically you will place. This is the difference. So you consider this one. This sphere at the center. Here it is directly touching 1, 2, 3, 4, 5 and 6. That's why if you join this one, it will be just like a hexagon. Just like a hexagon. That's why it is called hexagonal close packing. This center just forming a hexagon shape. So, one thing I will show you. You take any layer, either one dimension or two dimension or any layer, any type of packing you select. During the close packing, some voids, that is gaps, are formed in between the sphere. You see the gap. So, some gaps are formed between the spheres. So, these gaps is called as, these gaps are called as voids or gaps. And generally, voids are two types. Voids are two types. One void can be formed in this way. You take three spheres, then place over the three sphere, you place another sphere. Just like this is the three sphere. Now I am placing another one, third one. So the gap produced here, the gap produced in between these four spheres, first three spheres and second layer. This is the second layer. This is the first layer. is the second layer is produced. This is forming a gap. This is forming the gap. This gap between these four spheres, this gap is called a tetrahedral verse. It is called tetrahedral verse. THV, tetrahedral verse. Tetrahedral verse means if the verse produced between four spheres, if you place the fourth sphere over the third sphere. So another type of verse can be formed if you take three spheres, then you place another three spheres at this depression. At the depression. So this gap is called octahedral verse. Tetrahedral verse, another is octahedral verse. Octahedral verse, suppose you see here three spheres, you see the verse. Below three spheres and above another three spheres. Means second layer, first layer, second layer. You see the verse. So this verse is called octahedral verse. And the shape of tetrahedral verse will be just like a tetrahedron. Imagine 3D diagram. Just like a tetrahedron. And octahedral verse, it will be just like an octahedron. This type of shape will form tetrahedral type, octahedral type. That's why it is called octahedral verse and it is called tetrahedral verse. And tetrahedral verse is produced in between four spheres and octahedral verse is produced in between six spheres. So these are the type of verse produced in the closed packing. So let us discuss the third type of closed packing, that is your 3D. Closed packing in 3D, three-dimensional. Here in closed packing, three-dimensional generally form when you place first layer. This is the first layer. Then you place the second layer of the sphere. Second layer you place. Then suppose the first layer is A. Then second layer is your B. This is the A layer. This is your B layer. So when first layer and second layer will be placed, second layer over first layer, then verse will be formed. Already we discussed. Verse will be formed. So verse may be tetrahedral verse or may be octahedral verse. So if you place the third layer, when you form the third layer, first layer, second layer and the third layer, you have to select at which place, which point you have to place. If the third layer is formed at the tetrahedral are the tetrahedral buds. That means you place the third layer where are the tetrahedral buds. First layer, second layer, then third layer. Third layer are the tetrahedral buds. Then you will get what type of close packing? A, B, again A, again B. That means what? Repetition. First layer, second layer, then third layer. This is your first layer, second layer, your third layer. Third layer is the repetition of first. When you will get this type of packing, if you place the third sphere at the where? At the tetrahedral buds. At the tetrahedral buds, if you place the third layer, then we will get AB type. This AB type close packing is called hexagonal close packing. It is called hexagonal close packing. That means repetition. Third layer is the repetition of first. Similarly, if you select octahedral buds, third layer are the octahedral buds. You select the octahedral buds because so many buds, tetrahedral buds and octahedral buds. You select only octahedral buds. If you place at the octahedral buds, you will get A, B, and C. Then A, B, and C like this. That means the first layer, second layer, and third layer. Third layer is totally different from first layer and second layer. That is A, B, C. Again the repetition of A, B, C. So third layer is the totally new layer when you place the sphere at the octahedral buds. So this type of closed packing in 3 dimensions is called cubic closed packing. Cubic closed packing, CCP. It is called cubic closed packing. Cubic closed packing. CCP arrangement or hexagonal closed packing. So there are different types of closed packing possible in crystals depending upon the selection of voids where you are placing the spheres. Thank you all.